So this is section 3.3, proving lines parallel. So when we finish, we're going to be able to determine whether two lines are parallel. So let's get started. So we're going to start off with theorem 3.4, and it's the converse of the corresponding angles theorem. So if two lines and a transversal form corresponding angles, in this case it's 2 and 6, and if these angles are congruent, then the lines are parallel. So if you'll remember, the original statement said if lines L and M are parallel, then angle 2 is congruent to angle 6. So the conditional statement and its converse are both true. I think that's pretty cool. So let's go on to problem 1. So on this one, we're wanting to find out which lines are parallel if angle 1 is congruent to angle 2. So we've got angle 1 and we have angle 2. So these two are congruent. So let me mark that. So angle 1 and angle 2 are congruent, and we want to know which lines are parallel. So angle 1 and angle 2 are corresponding lines. Corresponding angles. So A is parallel to B, and M is your transversal. And that is the converse of the corresponding angles theorem. Okay, so let's look at this one. Which lines are parallel if angle 6 is congruent to angle 7? Okay, so angle 6 and angle 7 can be corresponding angles if we're talking about lines L and M. So we would say L is parallel to M. And what's my transversal? My transversal would be B. Okay, let's look at theorem 3.5. It's the converse of the alternate interior angles theorem. So angle 4 and angle 6 are alternate interior angles, and it says if the alternate interior angles are congruent, then the lines are parallel. Theorem 3.6. It's a converse of the same side interior angles postulate. So here, if the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees, then lines L and M are parallel. And let's look at 3.7. If angle 1 is congruent to angle 7, those are alternate exterior angles, then line L is parallel to line M. Okay, so now we're going to do a proof. This is a proof of theorem 3.5, the converse of the alternate interior angles theorem. This is a different style of proof. This is a flow proof. So we're given that angle 4 is congruent to angle 6, and we want to prove that angle L is parallel to angle M. So first thing we do is look at 2 and 4. We know those are congruent. For what reason? Vertical angles are congruent. And then we go to angle 2 is congruent to angle 6. Well, how do we get that? Notice we've got 2, 4, and then 4, 6. So we can make the jump that angle 2 is congruent to angle 6. What's that called? That's called the transitive property of congruence. And our last step, line L is parallel to M. So we've said 2 was congruent to 6. So if corresponding angles, 2 and 6 are corresponding angles, are congruent, then the lines are congruent. So if corresponding angles are congruent, then the lines are parallel. Okay, so we're going to write another flow proof. This one's going to be for theorem 3.7. So we're given that angle 1 is congruent to angle 7, and we want to prove that angle L is parallel to angle M. So we know that angles 1 and 3 are vertical angles. 5 and 7 are vertical angles, so that means all of those angles are congruent. 1 and 5 are corresponding angles. And 3 and 7 are corresponding angles. So what do we need? We need one pair of corresponding angles to prove that line L and M are congruent. So let's get started. I'm going to make it smaller so we can see the diagram. So angle 1 and angle 7 are congruent. So angle 1 and angle 3 are congruent. That's the vertical angles theorem. I'm sorry, vertical angles are congruent. So then we can say angle 3 and angle 7 are congruent. What's that property again? The transitive property of congruence. And L is parallel to M if corresponding angles are congruent. Then the lines are parallel. Okay, so let's look at number 3. The fence at the right is made up of pieces of wood arranged in various directions. Suppose that angle 2 and angle 1 are congruent. Our lines R and S parallel. So, what are lines 1 and 2? Okay, so I'm sorry, angles. Angle 1 and angle 2 are alternate exterior angles. So if angle 1 is congruent to angle 2, which is what they said, then R is parallel to S. And this is by the converse of the alternate exterior angles theorem. Okay, last problem. What is the value for X for which A would be parallel to B. So it's looking for the value of x that would make these two lines parallel. So what kind of angles do I have? I have same side, interior angles. Now what is the sum of these two angles if I were to add them up if A and B were parallel? Well, it should be 180, so 2x plus 9 plus 111 is equal to 180. So then I have 2x plus 120 is equal to 180. So subtract 120 from both sides, so then I have 2x is equal to 60. Divide both sides by 2, so x would need to equal 30 degrees.